We're going to do a little practice solving systems of equation by elimination, focusing on ALEKS type problems. You want to align all the like terms and then look at, do I have a variable that can cancel out? If yes, go ahead and add them together and do that. If no, you're going to need to multiply the equation by a number. And sometimes it'll be both equations. Then you are going to solve for the remaining variable, and then you're going to substitute or plug that answer back in to find the second variable. Looking at this example, you already have opposites right here with 2y and negative 2y. We can go ahead and solve by adding our equations together. That gives me 7x. My y's cancel out. And negative 8 and 29 is 21. So I can then divide both sides by 7. And I end up with x is equal to 3. Now I'm going to take that information and I'm going to, now that I know that x is equal to 3, I'm going to pick an equation. I'll just pick my top equation to put that in for x. So I'm going to have 4 times 3 minus 2y equals negative 8. That's 12 minus 2y equals negative 8. So I can subtract 12 from both sides, which leaves me with negative 2y equals negative 20, and I can divide both sides by negative 2, and that is y is equal to 10. That is my second equation. So if you were doing this on a pencil paper homework, I would write my answer as 3, 10. In ALEKS, you'll enter it in the spaces where it asks you to. On this example, when we look, my x's are not opposite and my y's are not opposite. So I have to do some multiplication here. And what I notice is that 2 and negative 8, I can multiply 2 by 4 to get 8, and then 8 and negative 8 would be opposite. So that's what I'm going to do because I'm allowed to multiply both sides by the same thing. So how I show that is I just put parentheses around the whole equation and put what I'm going to multiply by. And then I'm going to write mine over here where I have room. So 2 times 4, or 2x times 4 is 8x. Plus, and then 7y times 4 is 28y. And 4 times 25 is 100. And then my top equation, I'm going to leave exactly the same, but I'm going to rewrite it over here so it's all lined up again. So my x's cancel out. This leaves me with positive 25y, because it's a negative 3 and a positive 28, and 125. Now I'm going to divide both sides by 25, and I have y is equal to 5. So that is one of my answers. And I want to take that y value, now that I know that y is equal to 5, and pick one of my two equations to plug in. I can plug that into my top equation or my bottom equation. I picked my top. So negative 8x, I don't know what x is yet, minus 3 times 5 equals 25. So I'm going to simplify and get negative 8x minus 15 equals 25. Now this is an equation to solve. Adding 15 to both sides, so I get negative 8x is equal to 40. If I divide both sides by negative 8, I'm left with x equals negative 5. So my answer as an ordered pair would be negative 5, 5. In this example, there's not a single multiplier that I can multiply one equation to cancel my x's or my y's. So I can choose either one. I'm going to have to multiply both equations, and I'll show you what I mean in a minute. I'm going to choose to cancel out my x's. So I'm just going to put a little arrow right here to remind myself. So 10 is the number that both the 5x and the 2x can easily become. So if I multiply my top equation by 2, that gives me negative 10x plus 4y equals negative 42. And if I multiply my bottom equation by 5, that gives me positive 10x minus 15y equals 75. And so what I've done here is now I've created equivalent equations that one of my variables cancels. I have opposites now. So when I add my two equations, my x's cancel out. My y's become negative negative 11y, and this is positive 33. I can divide both sides by negative 11, and I get y is equal to negative 3. So I would enter that in for ALEKS if I were doing this problem in ALEKS. So now we know what y is, and we can replace in either one of our equations. I always go back to my original equation. So negative 5x plus 2 times negative 3 equals negative 21. We'll simplify here. That's like you have plus a negative 6. It's the same as subtract 6 equals negative 21. I will add 6 to both sides. Negative 5x equals negative 15. Divide both sides by negative 5, and I get x is equal to positive 3. So my point of intersection would be 3, negative 3. For this type of problem, you are given basically just two problems to solve in the same problem. If you're doing this in ALEKS, when I look at this first system, I can see that I don't have opposites, but I have the same number. So I could go through and multiply one of my equations by a negative 1, so I could switch all the signs. That makes my x's and my y's cancel out. So I have 0 on the left and I have negative 1 on the right. Since these are not equal, I know that this has no solution and I don't need to do any more there. For the second equation, I can do elimination if I want to. And my y's are still lined up and my x's are still lined up even though they're not in the standard form that we're used to seeing. And I have two that are the same, but they're not opposite. So I'm going to go through and switch those signs and then add. So I end up with 0 is equal to 7x, and I can divide both sides by 7, and I'm left with x is equal to 0. So that is, so I know this is going to have a unique solution, one solution, and my x is 0. And y would equal 9 times x, or 9 times 0. So y is also 0.